welcome to the deep dive.
Great to be here.
So we've had a lot of requests for this one, and it's a big one. The end of the world.
It is, isn't it? A topic that seems endlessly fascinating.
Totally. From ancient prophecies carved in stone right up to the latest blockbuster movies.
Yeah.
Humanity just seems completely captivated by this idea. Our planet's, ultimate demise.
It really is. It's this mystery kind of deep in our collective imagination, both, terrifying and weirdly compelling.
Exactly.
And while those fictional stories are often thrilling, sometimes pretty fantastical, science, in its own way, offers a perspective that's just as fascinating and maybe even more chilling sometimes.
Right, because it's grounded in, in reality or potential reality.
Precisely. We're not talking about one single sudden kaboom necessarily. It's more like a whole spectrum of possibilities. You've got cosmic dangers lurking out there, and then there are the threats we've frankly kind of created ourselves right here on Earth.
Okay, so let's try and unpack some of this. Today, we're taking a scientific journey, really, into these possible doomsdays, exploring the different paths our planet could take. We're diving into the sources you've shared with us, trying to pull out the key bits of knowledge, so you, listening, can get a really solid understanding of these, monumental scenarios.
Sounds like a plan. Where shall we start? Outer space.
But yeah, let's start there, the celestial stuff.
Yeah.
When we think about cosmic threats, what's usually the first, maybe the most dramatic image that pops into mind?
Oh, definitely.
It feels like the ultimate external force, doesn't it? The universe is just so dynamic, and Earth, we're just a tiny speck, really.
Absolutely. And the most popular one, the one that's kind of burned into our minds, and for good reason, is an asteroid or a comet collision.
Right, the big one.
Yeah, the big one. And Earth's history shows it happens. I mean, the most famous example, obviously, is the impact that's widely believed to have wiped out the dinosaurs, 66 million years ago, down in the Yucatan Peninsula.
Okay, so paint a picture. What does an impact like that actually entail? An object, say, over 10 kilometers wide.
It's almost unimaginable, the scale. It's not just a big explosion. It's a global reset button, basically. The initial impact energy. We're talking the equivalent of billions of atomic bombs going off at once.
Billions, wow.
Yeah, it would vaporize huge amounts of land instantly, and it throws this enormous plume of debris, dust, rock, way up high into the atmosphere.
Okay.
And that cloud spreads around the globe. It blocks the sunlight. That's what leads to the impact winter. Could last for years.
So just darkness and cold.
Darkness, plunging temperatures, photosynthesis pretty much stops.
Which means
the food chains collapse completely from the bottom up.
And that's not even all of it, is it?
No, not at all. You'd get secondary effects, too, like massive acid rain, which would devastate the oceans, the forests, and if the impact happened in the ocean, mega tsunamis, just scouring coastlines worldwide.
So the key thing is, it's not the bang itself that gets most life.
Exactly. That's the crucial insight. The immediate impact zone is obliterated, obviously. But for the rest of the planet, the real killer is the environmental collapse that follows. It's systemic.
That sounds utterly, utterly devastating. So, are we just sitting ducks then? Are there things we're doing scientifically to watch out for this?
Thankfully, no, we're not completely defenseless. There's actually quite a lot going on. Programs like those run by NASA are constantly scanning the skies, tracking near-Earth objects, or NEOs.
Okay.
So the good news, relatively speaking, is that the chance of a really big one, like the dinosaur killer, hitting us out of the blue anytime soon is, it's very, very low.
We'd see it coming.
We'd likely see it coming years, maybe even decades in advance, which gives us time, potentially, to figure something out.
Okay, that's somewhat reassuring.
It is, but, asteroids aren't the only potential cosmic threat, though the others are much less likely.
Okay. Now here's where it gets really interesting, right? Almost sci-fi territory.
Exactly. Like, think about a gamma ray burst. If a nearby star went supernova in just the right or wrong way, it could release this focused beam of gamma rays that could basically sterilize one whole side of the Earth in an instant.
Just fry it.
Pretty much. Or, even wilder, imagine a rogue star, one just wandering through space, passing too close to our solar system.
What would that do?
It could gravitationally mess everything up, destabilize Earth's orbit. We could get flung out into deep space or maybe drift into the sun.
Okay, those are definitely chilling thoughts. But the probability is super low.
Extremely low, tiny. These are more like cosmic horror stories than immediate scientific concerns we need to plan for daily. Still, fascinating possibilities.
Right. Okay, so let's pull back from the vastness of space and look inward. Down to Earth itself. Because the planet isn't just a passive rock waiting to be hit, is it? It's dynamic. It has its own immense forces.
Absolutely. Our planet is geologically alive, and that life, that energy, can also be a source of catastrophe.
So what's the big one, geologically speaking?
I'd say the supervolcano eruption. Think Yellowstone, or maybe the historical example of Toba in Indonesia.
Toba. When was that?
Around 74,000 years ago. And this wasn't just a big eruption, it was colossal on a planetary scale.
And the effects. Similar to the impact winter.
Eerily similar, yes.
Mm-hmm.
A super eruption like Toba would blast trillions of tons of ash and sulfur gases way up into the stratosphere. This creates a volcanic haze that, again, blocks sunlight, potentially for years.
So another global winter, but from below.
Exactly. Climate models suggest a global temperature drop of several degrees Celsius, widespread crop failures, mass starvation. It could genuinely threaten the survival of civilization.
Wow. Is there evidence Toba actually did that?
There's compelling evidence, yeah. Some scientists link the Toba eruption to what's called a genetic bottleneck in human history, meaning the human population might have crashed, drastically reduced around that time, possibly because of the eruption's climate effects. We almost didn't make it.
That's incredible. A single geological event having that kind of impact. It really mirrors the cosmic threat, doesn't it?
Yeah.
Just a different trigger.
It does. The outcome, this global environmental shock, can be remarkably similar. But the mechanisms, the timescales, they're different.
Are there other, maybe less explosive, but still profound internal threats?
Yes, there are. Another fascinating one involves something more subtle, Earth's magnetic field.
Our shield against space radiation.
Exactly. Solar wind, cosmic rays. And what's interesting is that this field isn't stable. It can and does flip. A magnetic field inversion.
Wait. The North Pole becomes the South Pole magnetically?
Essentially, yes. This happened many, many times in Earth's history. We know this from the geological record.
Okay. So what happens during the flip? Does it just switch off?
It doesn't switch off entirely, but it weakens significantly. And the reversal process itself can take thousands of years. During that long period of weakening, Earth is much more vulnerable to that solar wind and cosmic radiation.
Okay, so what are the effects of that vulnerability?
Well, it's not an instant apocalypse, but it could be bad. Massive disruptions to anything electronic, satellites, power grids, communications, they'd really struggle.
Our whole tech infrastructure, basically.
Pretty much. Plus, increased radiation at the surface could lead to higher cancer rates, maybe more genetic mutations. And over very, very long timescales, that increased solar wind bombardment could even slowly strip away parts of our atmosphere.
So it's less of a sudden bang and more of a slow decline in our protection.
Precisely. It's a prolonged period of vulnerability, a slow erosion of our planetary shield, rather than an instant knockout blow. Still, quite profound.
Okay, we've looked at forces from space, forces from deep within the Earth, things largely out of our hands. But now, let's turn to a threat that is, well, much closer to home, one that stems directly from us.
And that, inevitably, brings us to human-induced climate change. And this isn't some potential future scenario, is it? The sources are clear on this. It's happening now. You could describe it as a slow-motion derailment, a train that's already started to go off the tracks. It's a multifaceted crisis.
Multifaceted how? What are the big impacts we're talking about?
Well, the list is long and interconnected. You've got sea level rise threatening coastal cities where millions live, more frequent and much more extreme weather events, bigger hurricanes, longer droughts, intense heat waves.
We're seeing that already.
We are.
Yeah.
Plus, a massive loss of biodiversity, ocean acidification killing coral reefs, glaciers melting at alarming rates, huge regions turning into desert.
And then there are these tipping points.
Ah, yes. The tipping points, that's where it gets really scary. Things like the permafrost in the Arctic thawing and releasing vast amounts of methane.
Which is a powerful greenhouse gas itself.
Extremely powerful, much more potent than CO2 in the short term. That creates a feedback loop, more warming, more thawing, more methane. Or think about the potential collapse of major ocean currents like the Atlantic meridional overturning circulation.
What would that do?
It could trigger abrupt, massive climate shifts, particularly in Europe and North America. These aren't just gradual changes anymore, they're potential cliff edges. If we hit enough of these tipping points, the planet could be pushed into a state that's fundamentally hostile, potentially uninhabitable for large parts of the human population.
So the key difference here, compared to asteroids or supervolcanoes, is agency.
Absolutely. That's the critical distinction. This isn't a theoretical doomsday cooked up by nature or chance. This is a reality that we are actively developing through our collective actions or inactions. Science is basically screaming at us that we're nearing these irreversible points.
We're in the danger zone.
We're definitely in the danger zone. The sources suggest we're in the final stretch, really, to avoid the absolute worst outcomes. Our actions now literally determine the fate of millions, potentially billions.
That puts a heavy weight on the present moment. So, focusing on solutions for a second, what do the sources point to? What actually moves the needle on this?
It's consistently about a few core things. A rapid, drastic shift away from fossil fuels to renewable energy, number one. Big investments in technologies that can actually remove carbon from the atmosphere, though that's still developing. And protecting and restoring natural ecosystems, forests, wetlands that naturally soak up carbon.
And policy-wise.
International cooperation is key. Things like carbon pricing, making pollution expensive, and strong regulations on industries. There's no single magic fix. It has to be a huge, coordinated effort globally.
Okay. Shifting gears slightly, let's think about scenarios where maybe the planet itself is fine, geologically speaking, but human civilization collapses.
Right. Earth remains, but we don't. At least not as we know ourselves.
And perhaps the most visceral, immediate threat there is, a pandemic.
Unfortunately, yes. Scientifically, an apocalyptic virus isn't just fiction. It's a known historical risk and a future possibility. History is littered with examples. The Black Death in the 14th century, the 1918 Spanish flu. These things wiped out staggering percentages of the global population.
So what would a truly apocalyptic virus look like today?
You'd need a nightmare combination. Extremely high contagiousness, like measles or Omicron, combined with a very high mortality rate, much higher than, say, COVID-19.
What would that actually do to society?
It would be utter chaos. Healthcare systems would collapse almost instantly. Mass panic, breakdown of social order, supply chains gone. The global economy would just shatter.
We got a small taste of that fragility with COVID, didn't we?
We absolutely did. And COVID, while devastating, had a relatively low overall mortality rate compared to historical pandemics or potential future ones, a virus that was significantly more lethal but spread just as easily. The consequences are almost unimaginable. It could lead to anarchy, complete societal collapse, a massive reduction in population very quickly.
Okay, now, just for a moment, let's indulge the pop culture angle slightly. Zombies. It's everywhere.
Ah, zombies, yes.
Obviously, reanimated corpses aren't real. But is there any scientific parallel, however loose, to that kind of scenario? Something that mimics that loss of control, that societal breakdown?
It's a fun question, actually. And yeah, while literal brain-eating undead are pure fantasy, the concept taps into something real. Science fiction often uses zombies more figuratively, people losing control, driven by some external force.
Oh, like Parasite.
Exactly, or a fungus, or maybe a neurological disease that strips away reason and causes extreme aggression, and nature actually has examples. The most famous is probably the Ophiocordyceps fungus.
The ant zombie fungus.
That's the one. It infects an ant, hijacks its brain and muscles, forces it to climb up high on a plant stalk, and then kills it, sprouting a fungal stalk from its head to rain spores down on other ants below. It's chillingly effective mind control.
Okay, that is creepy. So a human version.
A human version wouldn't create Hollywood zombies, obviously, but imagine a pathogen, maybe a mutated fungus or prion disease, that caused widespread neurological breakdown. Extreme aggression, loss of higher reasoning, maybe spread through bites or fluids. It wouldn't be the undead, but you could have a plague of violent, mindless infected that could absolutely collapse civilization in a similar way to how pandemics operate.
So the zombie apocalypse is really a metaphor.
In many ways, yes. It's a powerful metaphor for how vulnerable our complex society is to something that strips away social norms and forces a brutal fight for basic survival. Whether it's a hyperlethal virus or some theoretical mind-altering pathogen, a biological collapse is definitely one of the fastest ways for Earth as we know it to end for humanity. It hits our biology and our social fabric simultaneously.
Right. It underscores how delicate that balance really is.
Yeah.
Okay, from these immediate threats, let's do one final zoom out. The grandest scale possible. The ultimate unavoidable end.
The cosmic endgame. Yeah, this one's not an if, it's a when, dictated purely by astrophysics.
And it involves our own sun?
It does. The death of the sun is the final curtain call for the inner solar system, including Earth. In about, 5 billion years or so, the sun will start running out of its main fuel, hydrogen,
And then,
and then it begins to change. It will swell up massively into what's called a red giant star. It will expand so much that it will engulf Mercury, then Venus, and almost certainly Earth as well.
engulfed.
Meaning our planet will literally be inside the sun's outer layers. It will vaporize instantly, just gone.
5 billion years is a long time, but
Yeah.
wow, vaporized.
But here's the thing. The devastation starts long before that final engulfment.
How so?
As the sun ages and starts its transition towards becoming a red giant, it gets hotter and much, much brighter. That increasing heat, even billions of years before the final expansion, will have catastrophic effects on Earth.
Like what?
First, the oceans will boil away, completely evaporate.
Gone with water.
No more liquid water. The ice caps will melt, obviously. All that water vapor goes into the atmosphere. This triggers a runaway greenhouse effect, far worse than anything we could do. Temperatures will soar.
So Earth becomes Venus, basically.
Pretty much a scorching, arid, lifeless hellscape, baked dry long, long before the sun actually physically swallows it.
So the end isn't just one moment of engulfment, it's a slow cooking process first.
Exactly. A slow, agonizing transformation into an uninhabitable world precedes the final, fiery oblivion. It's quite the cosmic perspective.
What an incredible and, yeah, sometimes really chilling journey we've taken through all these possibilities. After exploring everything from asteroids to supervolcanoes, climate change, pandemics, even the death of the sun, what really stands out to you?
You know, what strikes me most is that looking at Earth's potential end through a scientific lens, it's not just about doom and gloom. It's not meant to just be a horror story. It's actually a really profound reminder of how fragile we are, how fragile life is in this vast universe.
Right. Humbling.
Very humbling. But, and this is crucial, it's also a powerful call to action.
How so?
Well, think about it. The big cosmic threats, the geological ones, asteroids, supervolcanoes, gamma ray bursts, the sun's death, those are largely out of our hands, right? They operate on immense timescales, driven by forces way beyond human control.
Okay.
But climate change, our vulnerability to pandemics, especially ones potentially worsened by ecological disruption or global travel, those were different. Those are problems that largely we've either created or significantly exacerbated ourselves.
Which means
We also have the power to address them. We have agency. We can make choices, develop solutions, change course.
that's a critical point.
It really is. One of the sources put it beautifully, essentially saying, the question isn't if the Earth will eventually end physically. It will. The real question is whether human civilization will survive long enough to witness that far-off cosmic moment. And science, unlike maybe some fiction, tells us that our potential end, the end of civilization as we know it, is often directly linked to our own actions, our own choices. So in a very real sense, the fate of our world, at least in the human timescale, is largely in our hands.
So the possibility that Earth, as we know it, could end, it's not just some future inevitability to passively accept, it's a warning.
A stark warning.
And maybe the most important thing is what we decide to do with that warning, how we respond to it right now.
Absolutely.
It definitely leaves us all with a lot to think about regarding our present actions and the future we're building, or perhaps unbuilding.